Greeting my statistics friends. I wanted to make you this short video to talk about how to solve these problems we are asking about independence and the chi-squared test of independence. So in this particular example, I'm looking at chapter 10, homework problem number 1. And we're being asked about the pottery that's being found in these archaeological locations. And they give us this table, and the site type is listed, and then the type of pottery is listed. And you'll notice the actual data is in the pink cells, and then the rows are summed up for us, and the columns are summed up for us. And the reason that's done is because if we were to calculate this by hand, we would look at the row totals and column totals. Well, I wanted to show you how you can solve this using your technology and your TI-84. So the first thing I need to do when I'm looking at this problem is, carefully read the directions. And it says to use a chi-squared test to determine if site type and pottery type are independent at the 0.01 level of significance. So the first thing I'm going to do is answer question A, what's the level of significance? Well, that's 0.01. Got that part. Then it wants me to state the null and alternative hypothesis. And so remember, the null hypothesis always talks about equality. And so in this case, equality means are independent. So I'm looking for the one where the site type for HO are independent. So it can't be this for one. It could be this one, or it could be this one. Or it could be this one, right? So it could be this one because it's R independent, and it could be this one because it's R independent, not this one because it says not independent. And then the other thing that I'm looking for is if it's not independent in the alternative. So equality always in the null hypothesis, and some sort of inequality in the alternative hypothesis. So that would be the case for this one. So HO is they are independent, and H alternative is that they're not independent. And then number B here, it wants me to find the chi-square statistic for the sample, and then round to at least 3 decimal places. So let me show you how to do that on your calculator, and then also get a p-value so you can answer the rest of these questions. All right, so in my TI-84, what I do first is go to the matrix menu. So I do second and then hit this button, x to the -1, because that gets me to the matrix menu. And then I go over to edit a matrix, and I'm just going to edit matrix A. You can edit any of the matrices you want, but I'm going to do matrix A. And then in this case, I need a 3 by 3 matrix because I have 1, 2, 3, and 1, 2, 3, 3 rows and 3 columns. 3 rows, 3 columns of data. The fact that they've summed everything up for us is extra. The data comes in 3 rows and 3 columns. So I need a 3 by 3. So then I'm going to carefully type in all the numbers. Now, one thing I want to mention here is be careful because, as always in WebAssign, your example might be slightly different than my example. So the example I worked out a minute ago is slightly different than the one I chose here. Because remember, those red numbers means they are being chosen individually for you as a student. So I have to carefully make sure I've entered all those numbers correctly. So I have 74 and 62, 53, 78, 67, 68, 90, 69, and 67. So now I have the correct 3 by 3 matrix put in. So once I've done that, I quickly double check to make sure I have all my numbers right. 74, 62, 53, 78, 67, 68, and 90, 69, 67. Then what I do is I back out of the screen by hitting second and then mode for the quit. Then I go to statistics, over to test, and down till I find the chi-squared test of independence would be the rest of what would be written here. There's also the goodness of fit test, but that's for a different type of problem. We want the chi-squared test of independence. So then I hit enter, and we have two places here. We have an observed and we have an expected. We only fill in the observed. The calculator itself calculates the numbers for the expected, and it stores that in B. So we leave B alone. The calculator will fill in B for us. And if that's information we needed, we would go back to the matrix menu and look at B for that information. But for this problem, we don't need that information. So then I go down to calculate and hit enter, and it tells me what my chi-squared value is and what my p-value is. So for my chi-squared value, I have 1.0022, and it wants me to round to 3 decimal places, I think. Put in 1.002, right? That's 3 decimal places. And then it asks me, are all the expected frequencies greater than 5? Well, they are, right? Yes. What is the sampling distribution we'll use? Well, we're using the chi-squared test. And then what are the degrees of freedom? So remember, the rules for the degrees of freedom is you count the number of rows, which are 3, and you minus 1, so that's 2. And you count the number of columns, which is 3, and you minus 1, so that's 2. And you multiply that together. So 3 minus 1 times 3 minus 1. So 2 times 2 makes 4. So there are 4 degrees of freedom. And then, so next we move down to part C, where we find or estimate the p-value. And I look at my p-value, and my p-value is 0.9, right? That's pretty big. And so I look at this, and part C is my p-value is bigger than 0.1. Well, that's certainly true. This is kind of interesting here. This is a little bit of a typo from our textbook author, because our alpha is 0.01. So this really should say that it's bigger than 0.01. But this is not a false statement, but it's not particularly helpful in the context of this problem. But really, part D is the part we're interested in. Based on what we have for p-value and alpha, what do we do? Do we fail, reject, or fail to reject the null hypothesis? And since our p-value is bigger than alpha, 0.9 is bigger than 0.01, we fail to reject the null hypothesis. And remember what that means. Effectively, that means we know nothing about what's happening here, right? It's our tolerance for randomness is too high. So we interpret the conclusion, and at the 1% level of significance, there is sufficient evidence. So there's not sufficient evidence. There is insufficient evidence. Really, I would say at the 1% level of significance, there is insufficient evidence to conclude the site and pottery type are not independent. So I would really say something stronger than that. I would say at the 1% level of significance, we can make no conclusion about the independence or dependence of this pottery collection. Okay, So then I want to submit my answer and see how I did. And let's see here. I got each of those correct, so that's great. All right, I hope this video helps. If you have any questions, have any questions for me, just let me know by clicking the Ask Your Teacher button, and I'd be happy to try to help.